Let's compare two organic molecules. We have ethyl alcohol, also known as ethanol or simply alcohol, and we also have dimethyl ether. They both have the same molecular formula, C2H6NO. In other words, they have the same number of atoms in their molecules, but because they're arranged differently, in other words, they'll have different structures, and that's what's going to account for their different properties. Specifically, in this problem, it's asking why does ethanol have a higher boiling point? And it's going to come down to the intermolecular forces holding those molecules together. So you can expect the ethyl alcohol to have a higher intermolecular forces, which in turn means it requires greater energy to separate those particles from a liquid to a gas phase. Let's draw the Lewis structure to confirm this. So ethyl alcohol is an ethyl group which is there. They're giving us the structural formula, so you just need to draw it the way it's in the formula. So you have a CH3s are always going to go at the end. Oops. And then you have another carbon connected to two hydrogens, and then you have a hydroxyl group, call that an OH connected to the carbon, and that's what makes it an alcohol. Let's put the two lone pairs there for the oxygen. Now on the other side we'll put dimethyl ether. CH3 is a methyl group. They're always terminal, so let's put one on one side and another methyl on the other side. And these are connected to an oxygen in the center. And so when you have when you have an oxygen connected to two carbons, that's what we call an ether, hence the name dimethyl ether. So when you look at these structures, you notice that there's no possibility of hydrogen bond interactions with dimethyl ether because all the hydrogens are connected to carbons, which are nonpolar bonds. Now on the left, the ethanol, you can see that this hydrogen is covalently bonded to a highly electronegative atom, such as oxygen, fluorine, or nitrogen. And so that makes that bond highly polar, this bond in green. And I'm going to redraw this a slightly different way so it's a little bit more obvious. So I just redrew these two molecules facing each other just to emphasize how they're going to form hydrogen bonds. Remember, these are all, according to Vesper, these central carbons and the oxygen included have tetrahedral bond angles of around 109. Not on the screen it looks like 90 degrees, but they're going in out of the screen and they're all around 109 degrees. So just keep that in mind, because you might be wondering, well, how can I change that into that? Well, they're the same bond angles. I'll just highlight it in red. This side is going to be slightly negative and the hydrogen side is slightly positive, and the same thing over here. Maybe this is that way. So this interaction between the hydrogen, the positive side of the hydrogen, and the negative side of the oxygen is what we call a hydrogen bond. They're very strong intermolecular forces.